let's finish up this unit test stuff. After, you know, pulling our hair out earlier, let's fix this, right? So, um, first thing is, well, hold on, what's up with this? The stream says it's... Oh, you know what? Let's do the dashboard again. Hold on. My dashboard looks incorrect. It says it's streaming, so... Okay, there we go. Okay, so yeah. Okay, so now if we look at the chat, okay, we're good. All right, so let's get to it. So we need to add one more test to all of this mess that we have, and yeah, let's do it. So there's a lot of stuff here where it's like, where are we even? All this stuff, and then yeah, our dirty grow test, or is that what we call it, dirty grow test? Yeah, because the idea is we're gonna expand a region, a dirty rectangle, by meticulously kind of setting values inside of a certain cell at the correct X and Y values. We're gonna like diagonally set in a cell to, you'll see. So let's just take this because we want to clear everything for this set of tests, right? And then what we're gonna do is we're gonna say for t equals 0, t is less than or equal to 15, and t plus plus. And we'll do the same thing for u, or not u, but the sub. Sub less than or equal to 15, and sub plus plus. Okay. And within here, we're gonna set the we're gonna have a diagonal loop. So we're gonna do for int 32. Let's just call it diagonal x. Okay. Equals 0. Dx less than or equal to 15. Or is that correct? So that's not correct. In fact, this isn't correct right here. This, oh no, these are indices. These are indices. That actually makes sense. It's just the confusing part as when I'm looking at my diagrams here. Right, I'm seeing these 15s, and I'm like, oh, 15s, and this is not 15, right? But, 15 in terms of the index, right? A 4x4. 0 to 15, 4x4, 0 to 15. But this next inner iteration is going to be cell XYs rather than indices. So these are 1D indices. So this is, you know, at 1D index, right? That's what this is. So these are one-dimensional indexes here. But then down here, loop through dia var cell using at 2D index values dx dy. Okay, so that's the confusion. Why I'm a little bit confused about the values we're using. So now that I've cleared that out of the way, it is a 16 by 16 cell area, so we can do 16 minus 1, right, because it's 0 to 15 inclusive, and then dx plus plus, and then after we have that, we can just duplicate this line, right? Or maybe we can't, because we can't type. Okay, And then in here, okay. So dx, dy, for not for delta, but for diagonal, okay? D is for diagonal. Okay. Alright, so now that we have that, let's so how do we want to test that the dirty rectangle is kind of like growing, right? Well, for each range, if we're actually going to do a diagonal here, then when we're looking at the query, right? So we're gonna put something at T, S, and V, but V is going to be calculated by doing an index to XY. So index to XY C99, and we're going to take the variable one. We're going to take the V here. So I'm sure we've already declared a VX somewhere, because this is a monster of a thing. Yeah, we have I32 VX right out here, so we don't need to declare that again. Let's just reuse that. So it's kind of a mess. This test code is a complete mess. So this dex var, whatever. We just do index to XY. I actually want XY to index. What the hell am I doing? XY to index is what we wanted. Okay, so much simpler, right? So the width is going to be 16, and our TX value is going to be DX, and then our, well, hold on, our DY value right here, and then TX is the remainder, so DX here, and then the index is just the V value, right? So we're calculating the V value here. So we're going to put a thing here. And we're going to expect that for each time we put this, we're going to start with a 2x2, and it's just going to increase. So, so the span equals span plus equal 2, right? And the reason it's plus equal, or span plus 2, my bad. So this is a span, and let's actually put in a scope here. Good. Indent this a bit. So we can remove this to do, because we're doing it right now. For this span variable, the first time we set something, it's going to be at the 0, 0, right? And so that means that the rectangular region will be like 0 to we could call this width height, or width and height, because it's width on height. We could call it that, maybe. That might be better. So int 32, width height equals 0. And then in here, we're going to increase it. So the first iteration, when we're doing a query, we're going to see a 2x2 at the origin of wherever it is. And actually, so width height is equal to 0 here. Actually, we're going to do this. So width height should actually be, every time we do this, it should be equal to 0, right? Because we're going to try the test over and over and over again. And, so put, and then we're going to try to do a get T, S, V, and R. And we need macros for put and get. So over here in our scope, how do we do this? So we put the scope kind of above it. So let's do like undef put and undef get. And then the put and gets are just aliases for the dirty sector update and the dirty sector ask. Is that what we want to do it? Nah, I think we want to put the scope. Okay, there we go. Still kind of ugly, but you know, that works, right? We just want to make sure that we know this is a scope. Alright, so it's not like we just have some stray curly braces for absolutely no reason, right? And yeah, so this rectangle, we're just going to assume that we can actually do the calculations here to get the actual rectangle. But we could make sure that the rectangle dot x1 minus rectangle dot x0 plus 1, and it should be equal to the width height, right? So assert that this equals width height, right? And then same thing with the y's. So we're going to take the largest y minus the smallest y plus 1, because it's an inclusive range. And we're going to make sure that that is also equal to the width height, right? Because every time we loop through here, the end result will be an area that is 2 greater, right? Because when we set one dirty piece of data onto the internal dirty flags buffer, it actually covers a 2x2 pixel region, right? Because it's 2x2 pixels, but this is one cell, but it's 2x2 pixels. So the end resulting rectangle that we're querying is in terms of pixels. So that's why there's the multiply by 2. So we can write that down here. You know, y plus 2. Commentary before vid IID 0052, and the time is 0 minutes 13, or 0 hours, Jesus, 0 hours 13 minutes and 12 seconds. Okay, so if we want to know okay, so right, now we have a little commentary for, well, why do we have it this way, right? Well, we have the commentary linked to the video for why we're doing it this way, right? So, so we put it, we get it. The get stores the global position of the dirty data in terms of pixels, because we want to be able to just push this up to the GPU. And then we're going to assert that it is the proper size. And now, what we can also do is we can figure out we can figure out the exact dimensions that the rectangle should be right here, right? And to figure that out, well, we know we have t and s, so we have to do the we can do the index to xy calculations. So index to xy c99, and we don't need this one. We just need these ones. And, okay, and TX and SX, I'm going to take a wild guess and say that these are also declared somewhere already. So yeah, we got this TX and TY, we're already using them. I'm sure they've already been declared. So let's just use them over again. Are we in the correct space, or is this more is this where we wanted to be? Yeah, okay, we're where we want to be. So we're going to take the t value here, right? This, because this is the tau value, right? And then we're going to take the sub value. And bam, we got what we need, right? So, we could keep this a little bit shorter, be like, the cell is 4x4 cells. Right, we could keep this commentary kind of shorter here. Dia subcell is also 4x4 cells. Alright, so we're kind of explaining why do we have this magic 4 right there, right? Well, we have the answer right there. Good enough for me, right? So, we've been doing these formulas a lot all over the place, so I'm not gonna worry too much about if this is correct or not. Also, it's in a snippet that's been kind of proven to be true already. So, the remainder of how many full rows we can have is our x. Then we take the entire one-dimensional index, we minus the remainder, so that we have a number that's evenly divisible by 4, and that's how we get the number of rows, which is also known as the y value, right? So same thing here. The remainder is your x, right? Because we're using modulo. Remainder is the x. And however many full rows you can fill is your y. Okay? And that is a sensible formula for me. So the next thing is we should get the base x and the base... we should set the expected here. So here, what we're gonna do here is top left x, or base x equals tx times 128 plus sx times 32, right? And that's because these are 128 by 128 cells, these are 32 by 32 cells, right? So that's the base for the upper left. And I don't know if base x and base y is already declared or not. I almost feel like we'll just write it, and it probably is declared, because this is such a massive thing here. We can look through this really quick. This is why I should have used scopes, more scopes, because holy crap, this is why we put all of this kind of, all of this test logic at the bottom, because there's like, right, we're in the thousands, but we don't really have thousands of lines of actual code, and like, we have much more test code than actual code here. This is ridiculous. But yeah, so let's take this and, let's do over here, right? So we're in the scope, so we can do I32 bx, and this is bx, and this is base top left x, and I32 by, which is the base top left y. Okay, base x, base y. Which we're using the x, and no, these need to be y's here, so put y's here, okay? Make sure that all these colors are actually used, right? Because if they're not all used, then we've made a mistake. Okay, they're all used. The x's, cyan, and the yellow, and the, hold on. Okay, yep, cyan and the yellow. And then orange and purple for the y's. Okay, yep, that looks good. Okay, now that we have that, the next thing we can do, and did we clear this when we got into it? Yeah, we did the clear. The next thing we want to do is predict the actual expected rectangle value, right? So we are growing this rectangle starting at the 0, 0. So we always know that the we always know that the expected dot x0 is going to be 0, and the expected dot y0 is going to be 0, but the expected dot x1 is going to be that base x value, and then we're going to add on, so this is the, so we have the xy here, right? So it's going to be this xy value multiplied by 2 because each cell is too large. And also, we're going to add 1 because we're trying to get the lower right corner. And then the expected y equals the base y plus dy for diagonal y times 2 plus 1, right? And then we want to make sure these are true, right? And if we can get through this test, if we can get through this dirty grow test without a hitch, then we're fucking done. We're fucking done with these tests. Well, for the dirty rectangle stuff, we're done with it. It's over. And then we can go into all the other test code we need to write. But, you know, it's a pain in the ass to have written all this, but it gives us the sanity of mind that it's correct, right? Because if we don't have sanity of mind that all of this stuff is correct, the uncertainty is going to compound exponentially, right? As we add more and more and more systems that rely on other systems that rely on other systems, the uncertainty factor is going to become more and more steep. And the last thing we want is some type of really cryptic kind of bug that we just can't find because we didn't write detailed enough tests. Because I mean, yeah. So it's totally okay to have tons more test code than you have production code. That is actually fine. Because I mean, you want to make sure that production code works, right? So when we queried, we used the R for the return rectangle. And now for E, we just fill this out. And now we just want to make sure that if E dot, we'll do a 0, or E dot x0 not equal to R dot x0, right? So we're just comparing the rectangles, right? And if any of these, if any aspect of the rectangle doesn't match, then we have failed our comparison, right? We want to make sure that the expected rectangle and the rectangle we got are actually exactly the same, right? We're making some predictions about how this should work. And so basically we're kind of like going through each one of these cells here, then each one of these cells here. And when we get into here, we're gonna lay data. We're gonna lay the data diagonally, right? So we're not gonna go fill it like this. We're gonna relay it diagonally, and then we can predict how the dirty rectangle should be growing based on that, right? And possibly, if we get this right, we might want to try something else where we grow in the other direction, right? Where we start here and we grow in the other direction. But let's get this done first, and then we'll kind of think about if we want to add that as a test as well, right? Because we're adding a lot of test code here. So if this doesn't work out, we're just going to error and be like, I don't know. What do we want to put for an error message? Let's see. Bisexual lobster. I don't know. I like his. Oh well, he's not sexual lobster on YouTube anymore. He got changed to Greasy Tails. Anyway, so let's take this and run with it, I guess. I mean, if we get to this message here, then we're pretty much out of here. We might want to try to grow the dirty rectangle in a different way. But I'm pretty confident that that it works, right? If we can get this to work, I'm pretty confident that it works. I'm fairly confident we've solved all the problems. But let's just run this, fix some syntax errors, try to get this to work, and then I don't know, maybe it'll just be done for today. Because I already did stuff for 8 hours earlier today, so I'm just trying to. This is, as far as I'm concerned, this is extra credit right now. var because somebody thinks that this is JavaScript again. So v actually shouldn't even need to be declared. I'm pretty sure we've used it so many places in this test function that it can just use v and it's already declared somewhere. So it doesn't like my. Okay, so 2,207. That's a lot. So I think somewhere we have a bracket balancing thing going on here. And I'm honestly not. I'm not sure where that is, because it's pointing there, but I'm highly. Oh wait, it's not bracket balancing. It's one of those was not a semicolon. Okay, I got it. Okay, let's take another look at this. Okay, assertion failed. Alright, since the assertion failed, we're going to width height, right? So what we're going to do for that is we're just going to change it from an assertion to a to an if statement, so that we can kind of like print out some logic. So so if this and so if good. So otherwise, we're gonna throw an error. And error. I don't know what we want to do for a random message. Understand 5G strikes back. Alright, so I'm just reading random YouTube headlines and merging them together. So there we go. That will be our error message, and we should be able to print out the rectangles. So we should be able to do print rectangle and R. It's not. Maybe we shouldn't make a pun. And R. Okay, we want to print off that rectangle and see what that looks like, and then also print off width height. So printf and width height %d \n, and then the width height. Oh, you know what? I need to check in on somebody. See how they're doing. Josh, yeah. Hold on. 1 second. It's important. Okay, so anyways, yeah, let's do that. We'll see what that is, and that should be enough. We might need a macro for this print rectangle thing here. Because I don't know if it's defined in this scope or not. I mean, I've been using it everywhere. Okay, so the answer is no, I don't need it. And, so rec name is R, and it's 0103. So that is not what I would call a diagonal rectangle. It's a 2 by 4, right? The width and height is 4. So it's like correct on the X, but it's not correct on the Y. Right? So why is that? So it could be that the code actually doesn't work, or it could be that that we're not actually going diagonal and we think we're going diagonal, right? Okay, so anyways, so are we actually going diagonal, right? And the answer is no. We have an n by n loop here, right? We have an n by n right here. And basically, we want to go diagonal. So we're just going to hack it, right? We're just going to hack it. We're going to keep it dead simple. We're going to keep it goddamn dead simple. And, you know, if dx is not equal to... Okay, hold on. Well, if you're going to do that, then why do we even need the n by n loop? Why not just the d whatever, and then just go diagonal, right? Why all this extra stuff, right? Why is this necessary, right? Why not just go... right? Because they're both 16 by 16. So what we could do is, we'll call this diag. And then, right here, we're going to remove one of these. And this is diag. Okay. And this is, S and T. S, T. Okay, that's diag, and that's S and T. And now that we have this int32 diag, we'll just declare this I32 dx diagonal x, right? And then I32 dy, and this is diagonal y. Diagonal y, because I can't spell. I can't spell worth shit. Okay, so dx, dy. And so right in here, we're just going to say that, you know, dx equals diag, and dy also equals diag, right? So unnecessary amount of variables, because we're in the future. In the future, where C programmers can use variables like this, and it's okay, it's not a big deal. Okay, yeah, sure. So, yeah, so it is a little bit sloppy the way I'm doing some of this, but, you know, the thing is, this is just test code, and we're like, fuck it, let's just get it working. Let's not worry if it's too sloppy. So, diagonal, both the... Right, so we're gonna go move diagonal through it, right? And we weren't seeing a diagonal, because we were doing an n by n loop. Yeah, that should be good. And each time we move diagonal, right, each time we move diagonal, we are going to expect that the width height, right, this width height is going to expand by 2, right? So the first time the width height should be 2, right? Because it always takes up some room, right? After you put data, the data is not going to be 0, right? So we initialize to 0, we immediately put something there, and we account for the expansion of the dirty rectangle. So let's give that a shot and see what that looks like, you know? Okay, so anyways, let's give this a run and see what happens. So we failed. And, what happened here? So, the width and the height was good. The width and the height was good, right? So we passed this. But then our predictions on what the rectangle should look like kind of failed. So we should kind of figure out, well, why did our predictions fail, right? Because I thought we did that correctly. I thought we did the math correctly. Let's hope this isn't one of those, like, gotten. Let's hope this isn't one of those things that ends up taking up, 5 hours because we do something stupid and we can't figure it out. So, expected. And also, hold on. Let's make sure. I got too many tabs open. Okay, so let's give that a run so we can just see, well, is there something wildly different between the gotten and expected? Do we make a simple, stupid mistake? Like, how far off is the gotten value and the expected value? Do we just, like, are we off by 1? Because if we're off by 1, that'd be great. So x0, we got 32, 33... x0, 0, 33, okay. So the rectangle we got is at, oh yeah. That would do it. Okay. So let's go back here. So we're kind of being stupid again. This base value, so we got this dx, dy, yeah. We actually need the base value, but it's, but here's what it is. The calculation isn't always, it's not always 0, 0 for this lower bound, right? Because we're not always at we're not always at a cell. Like, for the first cells that we test, right, yes, the lower bound is always 0, 0, but once we get into these other cells, then the global position of that lower bound is not going to be at 0, 0. So what it really is we're going to take the base x and base y, right? We're going to have this base value, and then we have the dx value, right? And the dx and dy, we're going to multiply that by 0. This is always at 0, right? So we could say dx, dy, or we could just say 0, right? We could say 0, and then this is also plus 0, right? And we want to just keep that there. Obviously, this is like, well, what the hell is the point of this, that writing it this way? And it's just because I want to keep an obvious pattern here of the different sections of the formula that have been kind of, like, nullified, if that makes sense. And I think that might work. I think we're onto something. I hope. I can only hope. So, let's see what we got. Okay. Bam! Alright, awesome. Okay. So, that test worked. So, we looped through all this stuff. And we correctly predicted the the size of the dirty rectangle, as well as where the dirty rectangle was going to end up. So that's awesome. So like with this, I'm pretty confident that that this is working now. We might want to try something, some other tests that I don't know what other tests we could try. I feel like we've gotten this to the point where I don't know what else I could try. We could try to set we could try to set rectangles. We could try to set clusters of 4 and make sure that they are where we think they're going to be. Yeah, I don't know. There's a lot of things we could do, but I am fairly certain that we're good here. Okay, so I know we had some idea of like doing like going through like every single thing and just making sure that we could try this at least. We could try yeah, it's ridiculous. Like yeah, so, yeah, I think we should do one more test, and then I'm fairly confident this is gonna work. Yeah, I think iterating through every single pixel, and then if we iterate through every single pixel, and then map the pixel to the correct cells, and then set the dirty flags, in that manner to make sure that we've covered every single point. Now, if we do this, it's not going to correctly test how the dirty rectangle expands, but we've done some good tests here with testing the dirty rectangle expansion. So I'm not worried about that too much. But I think that we had this idea of doing kind of like something like this, which is commented out. And I think we might as well tackle that right now, and then I think we've done enough here. We're totally 100%. It's tested well enough, right? So let's do we'll say pixel by pixel test. So this will be the section for this. And we're going to do a loop that goes through every single pixel of our 512 by 512 texture. Oh, sweet. Okay, you're here? Awesome. Okay, so yeah, so test code is over here on my right monitor here. And so, it stops somewhere up here. But yeah, so like right here, okay, so maybe not 2,000. Maybe like more like 1,000 and some change. But the unit test code starts here. I always put my unit test codes at the bottom because of this shit right here. Right? But yeah, I had a function where, you see this min and max function right here? I have macros for min and max. I have a version of min and max that take a int32, but then I have another version of min and max that take a unsigned 8-bit integer, and I was using the wrong min and max here in the code, and I was ripping my hair out for 5 hours earlier this morning. But yeah, that is the code I'm working on. But yeah, I'm adding one more test. So I'm doing like a quad tree to, so I have a big texture that's 512 by 512, and it's going to store uniform values in a texture, and obviously you can't be pushing up a 512 by 512 texture every single frame of the game, so the idea is to keep a quad tree structure and only push up the dirty sections of the texture, right? And the texture itself is going to store uniform values. So they're not really uniforms. I call them texture as uniforms because I just store values that I use as uniforms inside of texture memory. So we just take the 512 block, we divide it into 16 subsections, and you use an enumeration to access one of these subsections, and that enumeration will have some type of category. And then we subdivide it one more time into 4x4 cells. So right here it's 512 by 512 with 128 cells, and then like 128 by 128 pixel cells. And then you take one of those 128 by 128 pixel cells and you divide it into a 4x4. And then you get 32 by 32 cells. You use some type of enumeration to access one of these cells. For example, accessing this cell will be Paint 5D. So all of the Paint 5D uniforms are going to be assigned to this cell here via enumeration. And then finally you get into a 32 by 32 pixel section. That is all of the uniforms that are going to be stored for a single subsystem. And each uniform is going to take up 4 pixels. That's because I used a lot of rectangles that need 4 data points. So I was like, screw it, every single variable is 4 pixels. Even if we're not going to use all 4 uint32s, we're just going to keep it uniform like that. So we have a quad tree-like structure for caching uniform values and then pushing them up to the GPU every frame. And so right now I'm testing that logic to make sure it is correct and making sure that the dirty flags work. So the dirty flags are actually an overlay over the 512 by 512 texture memory. You'll see we have this thing called Taudirt, that's texture as uniform dirty, and then Tau this file right here, these diagrams you're looking at, is Tau and this is where we're actually talking about the actual pixels of that texture memory. And this Taudirt is the quad tree overlay that goes over those pixels. And then Tau sync is for synchronizing. So Tau sync takes a look at Taudirt, it looks at the dirty flags, and it traverses the tree by looking at the dirty flags and pushes up the pixels that need to be pushed up to the texture memory. So that's what is going on. And yeah, so I'll be writing tests all day. So anyways, let's write this for PX. I don't know if we've even declared PX somewhere else already. Let's just throw it in. So PX and PY, right, for pixel X, pixel Y. And the next thing we want to do is we want to convert the pixel x, pixel y into the correct t, s, and v values. So how are we going to do that? So we want to well, we got to look at, we'll have to take well, here, so to figure out which t value we're in, so, or tx actually, so tx for tau x, so these are tx and ty for these cells. This is going to, these over here are sx and sy for subcell, and then over here are variable cells, so these are vx and vy. So if we want to figure out how to get these, we want to start from here, and we want to do tx equals px divided by 512. And the result of the integer division should just automatically truncate, so we don't need a floor command here. Just px divided by 512, and that will, well, not 512, what the hell are we thinking? 128, because their cells are 128 large. And we'll do the same thing for the y, right? So, same thing but y. Okay, and then once we have the tx, ty, how do we figure this out? We need the remainder, don't we? Yeah, whatever's left over, we're gonna use so let's do let's take this, let's indent this for a second. And let's actually add a scope here. So let's add a scope. And let's add a scope over here. So, you know, because we've been declaring variables all over the place, it's time to guard against, you know, littering. This unit test function is already long enough. We don't want to, like, throw in even more variable allocations into the scope of the top level scope of the function, right? So we'll just add a scope here, and then I32 will say we can call it Rx for remainder x. Sure, remainder x. Remainder x, and I32 Ry equals 0, and this is remainder y. Remainder y. Okay, so once we figure out what tile we're in on the on over here, we want to figure out what is the remainder. So we should be able to just do this, like Rx equals 512 minus the px times 128. Okay, and then for ry, we're going to do the same thing. Okay, and now with these, or hold on, not px, and it's tx. And let's change this into, okay, I see why the indentation is that way. It's because this, I wanted to align with that. Let's, if we really want to align like that, let's just do this, right? We got the space for it, so we can do it. So we got tx, we got ty, and then we multiply it by 128, and then we subtract by the 512, and then we get a remainder, right? And then we can do the same math over again to get the subcell, but the subcells are 32 by 32, right? So subcell x and subcell y is going to be the rx and ry, but divided by 32. Okay. And then we need to figure out the variable cell, so we need to calculate another remainder. So remainder is going to be, once again, a similar thing, but it's not going to be 512 anymore, is it? It's, well, we could do that, but it might be easier to wrap our brains around that, like 512. Yeah, it's going to be, actually, it's going to be easier to wrap our brains around it this way, so we're going to do it this way. We're going to say S thingy. I'll put a star here for now. No, I'll put a, I don't know, I'll put a dollar sign. Times 32. And we actually need another kind of thing here. Okay. So, I think it's easier to think of it like this when we're trying to get the remainder at this next level. 512 minus the tx and ty, right? And then we're going to go even lower. We're going to take that xx and sy, right? That was divided by 32 with the remainder here. And get the very last leftovers, which should be in the range 0 to 31. And we'll do some asserts as well to make sure that these calculations are correct. So Vx is going to be equal to... Well, actually, no. Vx should just be the remainder now, because there's nothing here to divide... Oh, actually there is, because we still want to figure out what cell we're in. And so Vx would be Rx divided by... and each one of these cells is... So 128 by 128 cells. These are 32 by 32 cells, and these cells are each 2 by 2. So we just got to divide by 2. And that gives us the Vx value, right? And then we're done. Then we're as deep as we can go. So Rx, Ry. Okay, so now that we have that, we want to do some asserts here, right? So let's just assert that tx is greater than or equal to 0, and tx is less than or equal to, or is less than 128. Well, hold on, let's think about it. That's completely wrong. Tx is... How did I even come up with that? So tx is between 0 and 3, so that would be very, very wrong. So let's do 4 minus 1, just so I can visualize that it's a 4 by 4. And then for ty, it's kind of the same assert, right? Okay, and then we're going to need something for the sx, sy, and that's also a 4 by 4 grid, so same deal. And then for the Vx, Vy, that is on a 16 by 16. So we'll do 16 minus 1. And yeah, so the thing is, like, maybe my math right here is not correct, right? Like, I'm just like, I'm pretty damn sure that's correct, but, you know, maybe it's not. And so... rather than to think too hard about this math here, we're just gonna do our asserts to make sure that everything's in the correct range. And is that a Kirby? What is that thing? Also, do you like my chat box? Yeah, I want my stream to serve as, like, video documentation, so I'll show you what I'm talking about here. So we just threw these asserts in here, right? So we could do a, right now the video integer ID is 0052 in the bottom right-hand corner. So, and then the time right now is 59 minutes and 18 seconds. And we aren't sure if this math is correct. So just throw in some asserts, right? So the idea is that as I'm kind of like doing this video here, I can throw in like little annotations to be like, this is the exact video recording and the exact timestamp that this happened. So there's no way in hell that even I want to go through all this video footage. So, you know when you write code and you're like, man, what the fuck was I thinking when I wrote this, you know? So, if I can remember to add more video annotations like this, where it's like, you wrote this code in exactly this video at exactly this fucking time, then we can be like, oh yeah, I remember what I was thinking because I have the exact video documentation of it, you know? Also, I kind of like... so that way I can't really make the chat box too large, but it is kind of fun because it's kind of like a King of the Hill thing, right? Where it's like, there's, oh, it's a Pokemon? I was thinking it was almost a Kirby. But yeah, so the chat box is almost like a King of the Hill thing, right? Because it's like, only one person's thing can be there at a time. Which I think might be interesting, or it might just be horrible if I ever get to the point where there's a lot of people watching. But I'm also thinking that if I want this engine to actually go anywhere, the best chance is to just have really good documentation. And so if I can use this stream to serve as like video documentation and to indoctrinate people, you know, maybe I'll have a chance, right? So who knows? We'll see. So, PX, PY. Let's do a sanity check. So, sanity check is transposition errors are something I do all the time. So I use my token highlighting and I do something like this really quick, where I'm like, make absolutely fucking sure that the X's are with the X's and the Y's are with the Y's, right? So we look at this and we see, yeah, that all lines up. So we're good, right? Now, that doesn't mean that we haven't made any transposition errors with, say, like the P's and the T's and etc. So we might want to also try another coloring scheme where the P's are one color, the T's are a different color, the remainder is a different color, the S's are a different color, right? And we can just make sure that the clustering of these colors is correct, right? So, I mean, so nothing looks out of place here. There's no inconsistent patterning. That is not correct. Patterning. There's, or we can just not say that. The patterns are consistent, right? So because there's consistent patterns in the code, I'm confident that this is written correctly. And I say that, but watch me get like 5 syntax errors when I try to compile this. So let's give it a shot and see if my build script. Okay, undeclared and... Oh, did I not declare it in the loop? Okay, so it's not declared in the loop. Let's just do... Let's not do it in the loop. Let's actually do it here, px, because we can actually say that this is pixel x. Pixel x. And I32py equals 0. And this is pixel y. And also, did I make sure... Yeah, it's 512 minus 1 right here. 512 minus 1. So I like to have my loops inclusive, so an inclusive range instead of a half open range. So I do 512 minus 1 here, so I can have my nice less than or equal to, which I'm sure drives a whole bunch of people crazy. Alright, so let's give that a run. I'm surprised I don't have any macros in this section yet. Oh yeah, we actually have to do something with this stuff, right? We got all these formulas, but we're not actually doing anything with it yet. That's why we don't have any macros. Expected blah 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 before whatever. So let's just look at this 61 here. So I did something wrong here, and it's kind of obvious. Okay. Okay. I keep on telling myself that if I don't use any IntelliSense, I'll just get better at not making mistakes. And then I do stupid shit like this. So SX is wrong. So the math for SX, whatever the math for SX is supposed to be, we did something wrong. So the remainder x divided by 32. So how are we gonna solve that? Is that really correct? Do we have that correct? Okay, 512, the TX times 128, and then whatever's left over there. Whatever's left over... Yeah, I'm not sure if my math is correct. Well... This remainder should be... If the remainder is, larger than... The remainder should be between 0 and 32, right? Yes, the remainder should be between 0 and 32 here. So let's just assert over here. Let's just assert that, Rx is greater than or equal to 0, and Rx is less than or equal to 32. And it's the remainder, so it actually is, it's not 0 to 31, it's the remainder, so it is actually 32, I believe. And, right, so this is another assumption of ours, that this remainder, alright, because now we're trying to figure out where we are in these cells. And, ooh, wait, hold on. 512, and these are 128 by 128 cells, right? So this means this would be so whatever the remainder is, it would be less than 128, but it could be almost 128. Okay, so yeah, so this should be, so this is wrong, because I'm stupid, so, 128 minus 1. This is what the remainder here should be, right? Right at this section, the remainder should be this. And, SX is, RX, divided by 32. Whatever's left over. It needs to be floored, but the C division will just do that. Yeah, totally. I'm actually I have been kind of like uploading them to YouTube as I've been going, because I don't have as much hard drive space as you. Like I know you have like, I don't know what kind of drive you have, but you have more than 1 terabyte, that's for sure. I just have a 1 terabyte hard drive I've had for like almost 5 years now. It's like a RAID hard drive, and right, the way I try to keep my code I try to keep my development space as lean as possible. So that's kind of like why you'll see me in like Notepad++. Yeah, exactly, like 86 terabytes. Yeah, like it's crazy. But I can kind of understand now that I've been like recording a whole bunch of these videos, where like one video is like a gig, and I'm like, oh fuck, I gotta start uploading this to YouTube. Because I'm probably gonna delete it from my hard drive eventually once it's all uploaded to YouTube. But yeah, archiving it on YouTube. And the idea is, right, I want to make sure that, like, regardless of, let's say I don't ever get any viewers, I want to make sure that it's content that I want to use, right? That it serves as documentation for myself. So I did, like, a whole bunch of, like, short C videos where I explained things in, like, under 30 seconds. Or, like, how to do something in under 30 seconds. Because, you know, all those programming tutorial videos, they're like, hey, if you want to learn how to do something like this, you're probably going to need to know how to do this. Blah, blah, blah. And it's like, don't tell me what the fuck I need to use this for. Why do you think I just Googled how to do this? Thank you for your intro that wasted, like, 5 minutes of my life. And so I try to do, like, videos that are, like, really fast. And then, like, I go back to them when I want to know how to do something and not have a stupid intro. And so every time I kind of see a video online about how to do something in C, I'll be like, okay, let's try to be the shortest video with how to do that in C. And I was doing that for a while. but it still takes time to even do something like that, especially to be that concise. So I gotta kind of pick where I want to put my time here, and I want to put all my time into this, because it's been like, I don't even want to think about it. It's been like 8 years since I did that game, and I've done a whole bunch of little prototypes, but I'm finally like taking those prototypes and kind of mixing them into the final engine. Granted, I was working on other things, like I've been working on the mechanical patents and whatnot, but God, it's still kind of depressing. But I guess, I guess things could be more depressing. You could be really old and have nothing to work on because you've already done it all. I don't know. Also, you should stream into the correct category, science and technology, so people can find your stream. Yeah, I don't even know what category I'm in. I was like, how the fuck do these knobs work? I don't know what the fuck I'm doing. I think I have a tag for programming, but, actually, let me search for the category here. You said science and technology, because I have the little science and technology. Alright, bam. Done. Upload. I don't know how it did it, but it just threw in creative and in real life as well when I did that. Or is science and technology? That doesn't make any sense. Science and... Let me try that again. Science and... good tags. Ask me anything. Yes, you can ask me anything. Will I answer anything? I don't know. Good question. Game development. Well, I am writing an engine, so there's a game development in there. Okay, bam. Done. Yeah, so I found that the tags... I always found I found that the tags and things are, like, really limited with Twitch. Like, it's like... You gotta use, like, the pre-defined tags that they say. Like, you can't, like, make up anything. It's not like YouTube where you can just be like, I'll tag it whatever the fuck I want. You gotta fit into the correct box. So... Yeah, programming. Yeah, I think... Game jam, cash game, and end game, gaming news, poker, mixed game. Okay, I got it. Anyways, I think, yeah, English, programming, AMA, game development, in real life, creative, science and technology. Bam, done. That looks good. Yeah, so, yeah, that is helpful. The first viewer I got was actually because I was trying to make a rendering engine for patent designs on shadertoy.com, and so I just logged my progress on Shadertoy, and then I put my, like, Twitch name in the source code I was writing, and somebody found me that way. Yeah, I know, I didn't think anyone was going to read the source code. Actually, I can go to Shadertoy. Let me go to Shadertoy really quick, see if I can find it. www.shadertoy.com. www.shadertoy.com. Please don't crash my computer because, you know, you're really shader heavy. Actually, we're gonna skip that, you know? Yeah, we're gonna skip that, you know, because, Shadertoy just kinda... here, I think you could do like a, tinyurl.com/sdf, 016 demo. That'll probably get you something I did on Shadertoy, but I'm not gonna open it myself because Shadertoy's OpenGL stuff, it's like, hey, let's start up 8 different OpenGL contexts in your web browser right fucking now. And it's like, why? Why did you do this to me? Why can't you just have, like, animated GIFs or, like, screenshots? Why do you have to do this? I mean, it's cool, but, like, my computer, I can't handle this. So, yeah, let's see if these asserts work. And, so I have this assert, and then the next remainder, we're going to assume that the remainder should be between... 0 and 255. So this remainder here should be between 0 and, we'll do 256 minus 1. And yeah, we'll give that a run, and we'll see where the asserts fail this time. And see where our assumptions on what we're writing is going wrong. Because I don't know. I just work here. By work here, I just mean I sit here. So 2, 2, 4, 7. And the remainder, 128 minus 1. So this remainder is somehow... This remainder calculation is not correct. So we gotta, so I gotta think about, well, why is this remainder calculation not correct? Like, what am I doing wrong in terms of my remainder here? This should be, like, simple tile-based math that I've done plenty of times, so it's like, this shouldn't be hard. But something we're doing wrong with calculating the remainder here. So we got the pixel X and pixel Y, right? And we're gonna loop through every single pixel in this 512 by 512. We're going to subdivide this 512 by 512 into 4 by 4 cells. Each cell is 128. So to get the Tx and Ty, right, these are the cell values at this level. So T is for tau. We're calling these tau cells, like diagram tau cell. So right here, this would be 1, comma 1, right? This would be 2, this would be 2, comma 2. This would be 3, comma 3. And the math seems like I'm screwing it up somehow. So maybe I should seed my asserts into... like, I know I kind of put all my asserts at the end, but I probably should put them interlaced where they're actually... or right after I do the calculation. It probably would make sense to put the assert there. Just to... I don't know, I just think it might make more sense that way, right? And then, let me make an update here. So in the video ID, so we're in video 52, and the timestamp right now is 1 hour, 17 minutes, and 28 seconds. And update is that we decided to interlace the asserts. Decided to interlace asserts. Right. So the idea is if we keep these nice little video comments, we can see what we were thinking at a certain point in time. Anyways, let's okay. Alright, so let's run this again and see where the asserts fail. And then we'll kind of... whatever assert fails first, it'll be the most relevant assert. Okay, so Rx greater than or equal to 0 and Rx less than or equal to 128 minus 1. Okay, so let's take a look at that. So that is 128 minus 1. It's on 2250. These lines are going to change quite often, but so the remainder, what should the remainder be here? Should it not be 128? Or less than or equal to 128 minus 1? And it's Rx, so very likely Ry has also failed as well, right? Because the formulas are all the same. We're going to take... so let's say we are at... we're over here in cell 2 over here somewhere. And we're looking at the X, right? That would be... we're assuming that would be 128, 128, and then something left over, right? And... to figure out how many 128s we have, how many full 128s we have, we're going to divide by 128, or we're going to get the TX, right? Then we take the TX and we multiply by 128. And, hold on. 512, that's not proper. Like, we're thinking about remainder. And then, yeah, okay, so I'm being completely stupid. So the remainder is whatever is left over. 512, you can't hard code this, right? The remainder is what... God damn it, I can't believe... So I'm being an idiot. I'm being a complete idiot right here. So the remainder is... it's px and py, right? Because you're going to take all the pixels. You're going to take all the pixels you got on the x-axis. You're going to divide by 128 to figure out what cell you are in on the x, and the same thing for the y. To get the remainder, we're going to take all of them pixels, take the whole chunks of 128, and then we're going to subtract that out, and now we have the remaining pixels here, right? Once we have the remaining pixels, we can divide by 32, right, to get the sx and sy. Now, if we want to get the next remainder, we're not going to put 512. This 512 is wrong. We want to do px and py again. So, we do want to make it easy to wrap our heads around this. So, we will kind of be redundant with our recalculation here, where we're taking the tx right here. That wasn't quite how I want to do it. So we're going to be redundant with our calculations and write this, right? So this statement was already written here, but I think it's easier to wrap my head around it if I just kind of like compound it in one line like this, rather than try to, like we could probably write this in a different way, but this seems like the most dead simple way to do it, because we could probably do, instead of px, we could probably do like the remainder x equals the remainder x minus this, and then we can forget about this part. But that's too hard for me to comprehend. I want to do it in the most dead simple way. So this is the most dead simple way, and we're not going to worry that, oh, we had to do a little extra multiplication, premature optimization, something blah blah blah. Okay, so now I'm fairly confident that I fixed a lot of things, so let's see if we trigger any of those asserts. So 2269. It's the VY and it's the VY value, so that's better. That's better, because that means that we got through a lot of the math, and it's just that VY value. Why the hell is it VY? Why is it VY that's failing first? So you know, I do every calculation as X then Y. So for the VY to fail instead of the VX tells me that I might have a transposition error. So VX, RX, VY, RY, so maybe not. So let's just color this again, right? Let's, X's and Y's, X's and Y's. Okay, I mean, everything kind of makes sense there. So I don't know why... Oh, well, Y is failing first because we're going Y and then X, and I get why I did that, because, you know, X and then Y, I always write X first and then Y first. But if we wanted to go in a correct scanline order, we're going to have to put Y on the outside, right? So, let's put Y on the outside. That means the X will fail first, probably this time. And let's make a note here that PY, then PX for the loop, so that we go in scanline order. And then we'll do the video integer ID is 00... Oh, I can't see the screen. Let me close this. 0052. And the time is 1 hour, 24 minutes, and 29 seconds. Okay. So now we know, like, if we want to know why we have PY, PX, we'll know why that is as well. And then maybe this will go somewhere, or maybe we'll just be really fucking pissed off because we'll see like a whole bunch of annotations littering the code, and we'll be like, man, this is really cluttered. Or maybe it's just a trade-off, man. So, let's just throw this. We got all this extra space. I don't like this extra space. Let's just... Okay, like that? Yeah, sure. Okay, so PY, then PX, right? So we swap that around. So we're not expecting the code to be fixed, but I just am expecting it to crash on X before Y now. Yeah, so VX is not within this 0 to 16 range here. And why is that? So what do we do for the VX? We divide it by 2. Let's look at our diagram, right? So we're making some fundamental mistake here. Well, the first thing is this RX. Is this RX? Oh, okay. Is this really a 256 by 256 block? It's not. This is not a 256 by 256 block. It's 256 individual data points after we take 16 by 16 and multiply it together. Or, sorry, no, 32 by 32, we multiply that together. Because it's all the pixels. And that's... Well, that's not even the answer either. So we got the math right here. 32 by 32, 1024, 16 by 16, 256. The RX and the RY here is for... the pixels that are left over, and what should be left over is something between 0 and 31, right? Because this final block is 32 by 32 pixels. So this assert right here is not correct. So we got to fix that. So 32, right? And then after we have that, does it make sense to take the remainder and divide by 2 to figure out what cell we're in? Well, each cell is 2 by 2, so dividing by 2 actually makes sense here. So my only concern, I guess, would be that that maybe this math is incorrect. I don't know what's incorrect. Let's just run it again. Let's run it again and see if a different assert gets tripped now that we kind of changed that around. And I don't know if that's going to be the case or not. So the VX and the VX kind of thing failed again. Okay, so now that that keeps on failing, it might be nice to know, well, okay, well, what is VX and why are we screwing up here? I thought it's a 16 by 16 grid. What's going wrong here? Dividing by 2. Yeah, so I have no clue. So what we're gonna do is, we're going to change these asserts into, like, a little if statement. So we'll do, like, if 1 and right? It's written a little bit weird, but it's that the idea is to keep it so that I can keep these statements kind of all lined up like this, because that's the way I like it, if nobody noticed that I was completely OCD and batshit crazy in the way I do things. But yeah, so if this is the case, then good, do nothing. Good, do nothing. And then otherwise, else, we're going to throw an error, and we already have a macro for the error that we need to throw. So it's just error and then some type of unique message. So we could say, like, I don't know, stream in the correct category. Right, so error messages, I really do not give a fuck what this error message is, as long, the only criteria for this error message is that it is a unique string within the entire code base. Because the idea is that when I see an error message, I'm just like, Control F into the code base and find it, because sometimes the error messages in the console get really cluttered. It's like, here's some bullshit, here's some other bullshit, here's some line numbers, here's some file names, and I'm like, that's too much to think about. Just give me this one token that I can look at and find exactly where it's happening in the code. So that's the way I kind of do it. So yeah, so let's just print f the VX value. So printf for a little since you say that printf isn't very intuitive, let me give you a little demo of printf. So, right, so the value right? And then it's a decimal value, and then a new line, and then VX, right? And then same thing here, we can duplicate this line, or we could just do it again for good practice, right? So printf, and then we're gonna do the VY value. So you notice that I write this in brackets right here. I write any type of hard-coded string inside of brackets so that I know it's a hard-coded string when I see it printed to the console, as opposed to like a generated string, right? So VX and VY. So now we'll have some chance to see, well, what's going on there, what's wrong, right? Unless I screwed up some syntax, we're gonna find out. Okay, so I didn't screw up any syntax. And VX is 15, VY is 0. And so what the fuck? Because that's actually like correct. That's proper. So I think I'm off by 1 with my assessment on the if statements, maybe. Oh, yeah, because we did the 16 minus 1, and then for some reason we are missing that, right? I don't know. Oh, also we have some more problems here. How the fuck? Okay, so put that there. And did we make that mistake, like, everywhere? Yeah, we made this mistake everywhere, so... Okay, so TX, the range is 0 to 3, right? But we write it like this as an inclusive range by denoting 4 minus 1, so that we can kind of visualize that it's a 4 by 4 cell area. Same thing with this other assert, 128 minus 1 is just a little bit easier to think of than 127, right? Because this is a power of 2. It's a little bit easier to wrap my head around. So this symbol here, so let's just color these symbols, make sure that's what we're using everywhere, right? 4 minus 1, 32 minus 1, 16 minus 1, yeah, okay, cool. So, we were off by 1, but I think now we shouldn't crash. I think that everything will work, but now we actually have to use these values, right? We just made sure that we had the correct values. Yeah, we just made sure we had the correct values, but now we actually have to use them, right? We did all this work, but we got to use them now. So yeah, the idea is we're going to iterate through every single pixel and figure out exactly what cells we're in, and that way when we do the get function, right, when we do the get and put, before we do this, we need to clear this data. So we have a nice little utility function, force clear for unit tests, and every time we do a different batch of unit tests, we want to clear all the dirty regions, right? We want to start with a completely blank, fresh canvas, and when I say canvas, I just mean bitmap or texture or array of bytes that we pretend is 512 by 512 pixels, even though there's no such thing as 2 dimensions in memory addresses, but we'll pretend. Yeah, but we want to clear all of this first. And then we have these defines for get and put. We're going to copy them and paste them down here because we're going to reuse them. And get and put is actually these functions here, dirty sector update and dirty sector ask. So I guess there are some context clues to what those probably do, because if we give them a define of get and put, then one probably puts data and another one probably asks about the data. So dirty sector update is marking things as dirty, and then dirty sector ask is just asking, hey, is this area of the quad tree-like structure, is it dirty, right? And this get function right here was just for the unit test. I don't actually plan on using it when I am syncing up the GPU memory, because it would be very inefficient to be batching out tons of these calls at such a granular level. So we're not really going to do it. We're just going to traverse the tree and clean it up as we go and push texture memory as we go. Dirty sector update, though, however, is used. We use dirty sector update every time we push a variable onto one of these chunks of 32 by 32 pixels. So what we're going to do now that we have everything partitioned out is forget what we were doing and be like, what the hell? That's what we're going to do. Oh, God, we have more transformations to do. So we go from pixels, right, and then we transform into tiles, and then we have to do another transformation. I didn't even think about it, but, so, we need to transform, tile chords. Tile chords are, 2D tile chords. The 2D tile chords, into their 1D index counterparts, because, every variable slot is an index slash enumeration, right? So let's take a note of where we are in this. So this is video integer ID 0052. It's like I keep on typing it. Why would I have forgotten by now? So we're at 1 hour, 36 minutes, and 15 seconds, like that. Okay, so let's actually do this. So we've done this so many times that we have a snippet for it. And we want to do index to xy. Or, sorry, no, we want xy to index, and we want a C99 flavor of this. And is that really my C99 version? That is shit. Let's do that again. It's probably correct, but xy to index C99. I mean, it'll work. I mean, this will work as a snippet. It's like, man, I'm disappointed in myself here. Yeah, so this index is fine. We need the index for T, index for S, and index for V. And we already have something for that. We already have the variables for that. It's called T. Just because this is the way we've been calling it in the unit test, so we'll just call it T. And, oh, hold on. There's some syntax missing from here. I think I know why, so let's go over to our shortcuts. Alright, so in our shortcuts that I usually don't show people, and I'm trying to keep all the sensitive information off screen, but let's not go over a column limit, so let's do index to, or xy to index C99, xy to index C99 for a second, and see what we got. So here it is. We can see we got some multiplication symbols and things that somehow were stripped out. And that's because the auto hotkey script doesn't like special characters a lot of the time. And the way we're going to subvert that is we need to put this into, instead of pasting the line, we want to paste some type of file, and we want to put the file name here. And we're going to store this file contents into that file name, right? So, so let's just do that right now. And those are some other notes. One of these days, these notes are going to be like porn links or something, and I'm going to be like, oh, fuck. But for now, I've been pretty good about that. So, let's take this, and we'll save it like in our shortcut files. It'll be in like our C snippets, where it's not C99. Well, technically I said it was C99. Whatever, it's in CXX because I don't really care if it's C99 or C11. It's pretty agnostic. It's like it's a very basic formula. It doesn't really matter what flavor of C it's in, right? And then in our snips folder, we'll do, let's see if we already have index to XY or XY to index. It's XY to index, right? So do we have XY to index? We have index to XY, but we don't have XY to index. So let's do a new folder, and we'll do XY to index. And we'll add this into our snippets. So we'll do XY to index, so XYTI for a little shorthand name for this file. The reason I use very shorthand names here is because all these things that are loaded into my shortcuts take up RAM. So let's not abuse that RAM any more than we're already abusing it. So yeah, that'll work for later. Right now we just need to take this for now, because we haven't reloaded our shortcuts, and we're not going to do that right now. Okay, so for the indexed xy, we're going to say that t equals, this would be tx, and then this is ty, and the width is equal to 4 in this case. And we'll duplicate it, and instead of t here, this is going to be, we have TS and V, right? So we can take TS and V and kind of column select and paste that where it needs to be. Now, for this last section, the width is not 4, it's a 16 by 16 subdivision. That's why you may have been hearing me say something like quad tree-like structure, because I have, there's no name for this, right? It's like a quad tree, but it's not. Because it's not quad, it's 4 by 4, so that makes it 16 here. So it's a 16 tree. I don't even know what you call that. I think it's like hexadideca or something like that, or hexadisextuple something or other the hell. And then even after that, well then once we get to here, this is a 16 by 16 cells, which is isn't that 256? Yeah, 256. So I don't even know what to call this kind of tree. So it's an irregular tree. It's an irregular quad tree. I don't know what to call it. So, anyway, so these variables, are they all the different? Looks good. Okay, so now we finally got what we need to, and why are we indented so far here? Oh, because I wanted to be lined up with this. Okay, that's fine, sure, why not? So we're gonna say that, we're gonna do our first we're gonna do our get, and we're gonna assume we want this to be clean the first time. We want we can do and r. We're not gonna use that, but we're gonna say ask equals get, and or you know what, we could just do this. We can eliminate that. We can just say that looking at our little notes file, we can see that the get command, dirty sector ask, these are what it can return. There's 3 possible valid states, and there's 1 impossible state. The impossible state is there's no way for you to query some data and that data to be dirty, but then the data is somehow outside of the dirty rectangle. That's impossible. But we could have 2 valid states for clean. If it's clean and outside the dirty rectangle, we're going to give it a 0. But if it's clean and inside the dirty rectangle, we're going to give it a -1, right? And if it's dirty and inside the dirty rectangle, we're going to give it a +1, right? So these numbers felt the most intuitive to me, because then the inside the dirty rectangle is still a 1 no matter what. But clean is always less than 1, right? So it just made the most sense to me. So that's how I decided to do the flags. So, with that said, we need it to be clean, and as we kind of set values, the dirty rectangle is going to change shape, so we can't be confident that these tests are always going to be outside or inside the dirty rectangle, so we just want to make sure that this should be less than 1, right? So, we could say less than 1 or less than or equal to 0. I think I like less than or equal to 0 better. Well, that's the valid state, so what we actually want to do is say that greater than or equal to 1, and, we'll say that we expected this to be clean. Air expected to be clean, 2020, or 2020, 1219. Now, we run out of room if we up. Expected clean 2020 1219, right? So just giving it a unique date. Sometimes I like giving it a date because if I get a little token here and then the exact date, it's unlikely to collide with anything in the future. And it also helps me, like, when I'm reading through code that's old, I can be like, oh, when did I write that? And I can see this little message here. I can be like, oh man, this code base, it's really old. Look at that date. Oh, look, isn't that nostalgic, right? Stuff like that. So yeah, when we get the value on our little quad tree like structure the first time, we're assuming that that value should be clean, right? Because we haven't marked it as dirty. Then immediately after, we're going to use the put command with the same exact parameters, t, s, and v, and this is going to mark it as dirty. And now we're going to expect that when we use this command, rather than greater than or equal to 1, if we look in our documentation, we should have 0 or negative 1. So it's going to be less than or equal to 0, less than or equal to 0, right? And, hold on. Hold on. So the first time we want to make sure it's clean, right? Why do I keep screwing this up? Yeah, the first time we want it to be clean, so we want it to be, we got this flipped around. We got this topsy-turvy land. Less than or equal to 0, right? Because if it's 0 or negative 1, these are both our clean states. And the next time we call it, we're expecting dirty, so we're expecting 1, but we'll do greater than or equal to 1, right? We'll allow room for expansion later. Also, I'm just not a fan of exactly equal to something with comparisons. I just feel like that's too error-prone. So yeah, the first time we're going to expect it to be clean, and the second time we're expecting it to be dirty. Okay? And, yeah, so that's all for this test code. So the next thing we got to do is we just got to run it and hope that we haven't screwed things up horribly. So yeah, let's, we could, alternatively kind of do the put right above here, right? Which is, you know, you could argue that that's horrible formatting, but it's nice to see the T, the S, and the V kind of line up right there. So yeah, let's give this a shot, see if, we have any mistakes, see just what happens. I don't know what's gonna happen. Okay, so expected clean 2020 12/19. Okay, so let's look at that. So if we put a value, right, and let's make sure our macros are correct. So put is dirty sector update, and then get is dirty sector ask. So basically, mark a sector as dirty, and then ask if that sector is dirty, right? And it's failing on the where we expect it to be clean. Expected, lost track. Let's just run it again. Okay, pick a color. Okay, expected it to be clean. So let's go and look at this. Okay, so expected to be clean. So it's failed here already. Now, that could be... we got less than or equal to 0. In our documentation, is that correct? Yeah, less than or equal to 0 would be clean. And... okay, yeah. Yeah. Okay, yeah, I see what's going wrong here. So, remember that each variable, when we're storing it on the texture memory, is exactly 2 by 2 pixels. Right down here. And right now, we're going by, we're moving by 1, right? So, the second time we set, like, if we set something in here, and then later we set something in here, we're still in the same region. If we set something here, there's 4 different places we could place data, where it would still count as being in the same sector of the of our dirty tree. So what we need to do is we just need to account for that, and instead of this plus plus, it's plus equal 2, right? So if we're here, the next time we're gonna add 1 and 2 and be in the next block. Okay, so let's make a note of y plus equal to 2, c vid iid 0052. Time is 1 hour, 49 minutes, and 57 seconds. Okay. So, you know, instead of Y and then the C, we can just say Y and then say the timestamp, right? Okay. So that's pretty good. Let's give that a shot and see if that works. If this works, we're done with our test. We'll have to clean up this, delete all this, get rid of this little log message, and we'll be good. We'll finally be done with the test for this subsystem. I mean, or the sub-library, you could say. I mean, there's other components to this. Expected clean. Okay, well, we're not done that. We're not out of here yet, are we? Huh. Well, first of all, let's just get rid of this, because this is clutter anyways. Let's get rid of this, because we don't need... Let's just get rid of this all now, right? Let's just get rid of all of it now, because we're getting really close, and we don't need any of that stuff. And let's just try to figure this out. So, what's going wrong here? Why are we getting... Right, we're going... If we're doing all of our math correctly, then this should all just work. I don't know... Right, we're so damn close. We're like a few things away from just being completely done. Plus equals 2 makes sense. The other thought is, well, maybe this isn't cleaning everything like I think it's cleaning, right? We've been using it over and over again, and we've had confidence that it works, but maybe it doesn't work, right? Maybe we found a bug in that, and then we have another problem. I mean, it's force clear for unit tests, and it's not meant to be used in any other capacity, but still, if it doesn't do what it says in the tin, that's a problem. Fuck. I don't want this to be another tearing my hair out for 5 hours thing. Is it 16 by 16? It's a 16 by 16, yeah, correct? Yeah, I don't know how we would, check to make sure that we're not getting any overlap. I guess what we could do is we could have, like, a previous, T, S, and V, and make sure that the previous is not... We just need a previous, V value, right? And the first V value we're expecting at, okay, so let's do a little smoke test here. So, if px equals 0 and py equals 0, then we're going to expect that, if v is not equal to 0, that is a mistake, right? Okay. And also, what we could do is, else, we'll create a previous v and previous a previous v value if T equals PV, previous, or sorry, we'll do V. If P equals prev V, then this is also a problem. V is prev V. Okay, that's a problem. And then right down here, we're going to, at the very bottom of the loop, we could do that. Or where are we calculating V, right? So V is here. We could actually do pre-V close to where it's actually being used. So right before we calculate the new V, we can just do prev V equals V. And, right, we're not going to compare it the first time. So when Px and Py is 0, we're not going to even look at that. Right, because the first value of pre-V isn't even going to be valid anyways. And then we are in a scope, so we can declare this up here, and it's not going to bloat our unit test any more than it needs to be. So previous V, so this is a, you know, previous V value, right? Okay. So now that we have the pre-V value, let's give this a shot. And also we can make a notation of when we added this as well. Maybe we're getting a little bit too crazy with this. I don't know. But I'm banking on this to actually help me in the future. So let's just keep on doing 1 hour, 56 minutes, and 44 seconds, right? So there we go. Okay, yeah, so let's give that a shot and see what happens, right? So I'm thinking that maybe, right, we're getting this error to trigger right here. So what I'm thinking is that the previous V value must be getting duplicated somehow. Like the previous V value is the same, and that's not what we should have. That's not what we want. So let's see what happens, right? Okay, give it a run, and not what I was expecting again. So we still got this. That's kind of scary. That's like, uh-ohs. I'm scared. T, S, and V. And we got the put, T, S, and V. Well, we expected this to be clean, so the first time... Okay, so what is the actual values, right? So what's Px and Py right now? So when we get over here, printf, what is Px and Py at the time that we realized that we expected this to be clean, but it's not? Like, what are those values at this point in time? How soon into the loop is it failing? I think that would be important information to know. So let's put that there and take another look at this and see if we can finally get through this. What I'm hoping is that, you know, I'm hoping I'm just making mistakes in my debugging code and that it's not a problem with my actual logic in the main function. Because, okay, well, that's, yeah, so we failed on the very first. So the good news with that is, the good news with that is we don't have to worry about it having reused that V value or something, right? Because it's failing on the very first, right? So it's expecting it to be clean, and it's not. So TS and V, and this is our get function, right? And up here, here's our scope. And did we not do a force clean for unit test? And the force clean does not quite work. Somehow, magically, we've gotten through all of our tests without any problems, and all of a sudden, it does not seem to be working. So, well, that's kind of like, oh, not that shit again. TS and V. We gotta make sure that TS and V are, well, we already bound checked TS and V, did we not? Oh, I don't think we did. So TS and V right here, we need to assert that they're in the correct range, right? I mean, we already did this math here, so we're assuming that it's correct. But let's do some asserts here, make sure. So we're gonna assert that t greater than or equal to 0 and t is less than or equal to 16 minus 1. Duplicate this, TS and V. Okay, so that's not correct. It's actually, this is 4, no, it's because it's 4 times 4. It's 4 times 4. So it's 16. Never mind. This is 16. This is 16, and this is 256 minus 1. Right, because these are the index values. That's correct there. And this might actually throw a compiler warning, because I believe these are unsigned, so it's going to be like, oh, this comparison is always true, fuck you, don't use it. And if that's the case, we're going to do a little hack to allow us to write it that way, because, well, what if we, yeah, always true due to limited range of data type. So, yeah, that's fine, but, like, what would happen if eventually we accidentally change the data type of TS and V, and all of a sudden it can go negative, right? So what we're going to do for that, to fix that, is we're just going to do a I32 cast, and then after we cast it, right, the compiler is still pretty smart, so we have to outwit it, and we got to also put a +0, which looks crazy as hell. So, so right here, we could also make a timestamp here. So, video integer ID is 0052, and the time is 2 hours, 2 minutes, and 19 seconds. Okay. So if we want to know what the hell was I thinking when I wrote this, now we know what the hell we were thinking when we wrote this weird-ass cast with the +0, right? So let's give that a shot, and we are kind of hoping that the assert gets triggered, because we're trying to find the source of our problems. Comparison is always true to do limit range of this bullshit again. So, so we were good here until we got to 256, because, well, yeah. And now we're, like, out of room. We're, like, out of room for this. This is, you know, we could try to, like, call this A, and then we could, like, you know, do a define right here, and now we're getting define A assert, right? And now this is just gonna get ugly as hell, but let's just keep with it. Undef A. And, we want to do the I32 cast of V and the +1, or the +0, sorry, the +0. We do need the +0, like, the compiler will complain if I don't +0, so it'll catch me if I don't do this, so, now we're, like, we are tight for space. Let's see if we can just, yeah, we're tight for space now. Let's try to line this up kind of the same. And, yeah, we are tight for space. So let's put this in the 10s and 1s place. Yeah, I don't like kind of making it this kind of dense, but I would rather not have these asserts span 2 different lines, so this is the way we're going to do it. Let's give that a shot and hope we didn't make any syntax errors with that, because that's kind of wonky the way we wrote it. Okay, so expected clean. We're still getting that error. So we know that TS and V is in the correct range, and that's good. Are we wrong with our notes here? Less than or equal to 0. That covers these two clean scenarios, right? Yeah. So I'm not really sure why this is... Well, I'm kind of thinking that, well, this means that, TS and V. What is TS and V at this time? All right. Let's actually look at what TS and V is as well. So, let's take this and go just paste this. So paste, duplicate it 2 times, make a little visual space here between the things that we're printing out here. And we have the TS and V, right? So TS and V, and let's just see what those are. What are those values? It seems to be failing on the very first pixel. And let's just see what we have. See if there's anything unusual. The asserts would say that no, there's nothing unusual. I swear to God, this better not be another unsigned signed problem where I'm doing everything correctly, but I'm passing the wrong theme to a function. Like, I'd rather not that be the case. So TS and V, PX, PY, it's all zeros. So that's very strange that, it's all zeros. Are we... No, these loops are different. Well, just because the loop... No, the loops are different. I don't know. There's nothing there. So I'm going to do this, because I'm kind of, like, convinced that the force clear isn't working, which doesn't make any sense, but this first usage right down where we're using it, it is... Well, also we're putting this in a variable, so, or we're not putting in a variable, we're using it inlined. I wonder if that affects... let's not worry about that. Let's do... Right, so this here, right here, is what we're doing, and, right, but TS and V right now should all be, should be just, 0, 0, and 0, so we could actually put that there, as is, and, we can get rid of this, and, this will be, I don't know, WTF, 2020, 12, 19, 7:34 p.m., 7:34 p.m., okay, and TS and V is, T equals 0, S equals 0, and V equals 0, right? That's the case at which this is failing, and so we're going to clear for unit test. We're going to try this one case that seems to be failing, even though we cleared for unit test. Then we're going to do it again, and we're gonna assume that this is going to get triggered, and if this doesn't get triggered, then there's something else going on that I don't realize yet, so let's give that a shot and see what happens. I don't know what's going to happen. Something that I did not expect. Assertion failed. Expression, blah, blah, blah. Did that happen because of my... Okay, so that was not what I expected at all. Is that really because of the extra code we wrote here? Or did I not test it after I did the okay, so we got a problem here. When we add this code in here, it changes things. It's not like the force clear might not be an idempotent command, and it should be. It should be an idempotent command, but the results we're getting are kind of saying something is changing where it should not change. Oh god, god damn it. Okay, I don't know, man. Line 588 in Taudirt.f. We have one of our assertions is failing. And that's in the main code, so something about adding this is actually triggering some assertions. So something about this might not be correct. So AAC 2020 to-do manager vital check force clear code, right? Because I think that this force clear code might be improper, but I'm gonna I don't know, it's not yet 9, so I guess we should kind of keep it going, but I don't know. Yeah, let's comment this back in. And let's look at where that assert is being triggered. Try to figure that out. So it is on line 588. So that tells me it's like in the actual code that it's not in the test code. So Control G 588. Let's roll up here and so we got these asserts. Oh, so this is just a bound check with the dirty sector ask. And we're making sure that we convert it to int32, we add 0, we make sure that it's less than. So these are just the bound checks. So that means we're calling it with the wrong things. Why didn't that get triggered before, though? Well, what the hell? What the hell? Okay, hold on. What the fucking hell, man, though? So if that's what's getting, and let's remove some of these breakpoints from some older stuff we were looking at. And there may be a lot of them. Okay, now we're only looking at these 2 points. So somehow it's getting called with bad oh, well, that would be a mistake. So T, this needs to be S. T, S, and V. No fucking wonder. Okay. So that's just me being stupid, but I had asserts in my code that caught my mistake. So that's cool. And let's just give this a shot and see what happens, because I don't know what's going to happen anymore. What the fuck, 2020, 7:34 p.m. So let's take that, copy that, and see where that's happening. So that's the new thing we added, right? Oh, this thing right here. So I did not expect that. I was pretty sure that our force clear was working, because we've been using it over and over again. So that is kind of, let's make sure it's not, because we don't, let's do this. Let's do ask. I don't think this should make a difference, but, let's do this. Right? I don't think that should make a difference, but let's make absolutely sure that that is not a reason. It's not like a function call as a post-increment, pre-increment kind of thing. So that shouldn't matter. But let's make sure, you know? Maybe I was wrong. So we're still getting the what the fuck message. So I just wanted to make sure that so yeah, it looks like the force clear for unit tests that doesn't actually work. But we've used it so many times in all these other tests, and all of our tests had plenty of problems, and then we fixed the problems, and now we're saying, oh, that's not actually a thing, that's kind of surprising. Jesus Christ. Yeah, I don't know. Now we're stuck again. We're like so close to the end of these tests, and now it's like, oh, nope, fuck you. Yeah, I don't know. The force clear for unit test, is it, it might not be going through the, I'm thinking it's not going through the individual, data points. Maybe it's just clearing the, it's clearing the, force clear for unit test, so it's clearing the actual CPU pixels, that's good. It's clearing the dirty flags, but is it clearing our conceptual dirty 3 flag? And it looks like it is. Is the loop correct, right? Are we not, right? We have this D1, D2, D3 kind of thing. It looks like we're using some macros, right, to do this nested kind of access here. So everything there should actually be correct. So some other weird bullshit is going on that I think it's some type of weird, like, stuff where it's like, it's like the, thing where it's probably something my compiler should be catching, and it's not, even though I try to be as strict as possible, but I guess I wasn't. So yeah, I don't know. I'm gonna stop the stream because I've already done like 8 hours of coding previously today, so that puts me at 10 hours for today, and I need to take a shower. Yeah, I don't know what's going on. I'll find this out later, but I'll see you around. I don't know what's going on, and I'm sick of this. So I'm gonna take a shower and then eat food, I guess. Yeah, that's what I'm gonna do. So later.